All right, welcome back. Hononegah geometry. Today we're going to do our first one that's not going to be a rigid motion. So today we're going to talk about 4.5 dilation. Before we get into that, let's do a little bit of a warm-up here now. Describe the congruence. Now, you'll notice that this is definitely not a translation because ultimately you're seeing this dot rotate around, and it's rotating around a full 180 degrees. So that is a rotation. And we're not erasing there. There we go. A rotation 180 degrees. All right, let's talk about dilation. Identifying the dilation. The dilation ultimately has a scale factor. You're talking about a situation in which you are expanding, okay, or reducing a figure. And so a dilation has a scale factor. It's transformation in which the figure is enlarged or reduced with respect to a fixed point. C, called the center of dilation, and the scale factor K, which is the ratio of the lengths to the corresponding sides. Here's the one thing I'm going to say, and I'm sure it's on my next slide, but anytime you're doing a scale factor, you're always going to put the new divided by the original. So anytime you're trying to find a scale factor, you're going to put the new length on top and the original length on the bottom. Here we go. The dilation with center C, scale factor K, maps every point P figure to the point P prime, so the figure, all the following are true. P is at the center. P is not the center of the dilation. P is the center of the dilation C when P equals P prime. If P is not the center of the dilation, then the image P prime lies on C to P. So notice, if I'm going from P to P prime, okay, you're going on a ray. This is what I was talking about with the last one. Whatever the new distance is, which is going from C to C prime, that is your new distance divided by your original. So if you're technically talking about this, it's your image distance over your pre-image. I prefer new over original, but this would be the original. Now, if that scale factor is bigger than 1, that would be considered an enlargement. If the scale factor is between 0 and 1, you would consider that a dilation would be a reduction. So we got enlargement or reduction. So here we go. Find the scale factor. The new is 12. Notice there's P prime. And so the original is 8. And so I reduce that. So we have a scale factor of 3/2. And so that would be considered an enlargement. That number is greater than 1. So this would be the scale factor. That would be an enlargement. The next one, the new length is 18. The original is 30. Reducing that fraction, both divisible by 6. So reducing that fraction, I would get 3/5, which makes it, because it's smaller than 1, a reduction. In a dilation, C to P prime equals 3, and CP equals 12. The prime means that's the new one. The C to P is the original. That makes this a reduction. Next. If P is XY, if I want to do a scale factor, I simply distribute the scale factor to both X and Y, and that would be my new point if the origin, and by the way, everything for our class will be from there. So the origin is where the dilation would come from. So here we go. If I have points 2, 1, 4, 1, and 4, -1, and I want a dilation with a scale factor of 2, then A prime would be 4, 2. Notice I multiply both by 2. And so B prime would be 8, 2. And C prime would be 8, -2. And so picking a little color here, I'm going to do the original. So +2, +1. positive 4, positive 1, and positive 4, negative 1. So this is my original A, B, C. And so if I do a dilation of 2, now I have the point 4, 2, pick a different color, 8, 2, 8, negative 2. And so notice the new figure is twice as big as the old one. So if you want to do a dilation by a factor of 2, just multiply everything by 2. Now I have the next one, and I want to do a scale factor of 1/3. So I'm going to take each of those points, and multiply by 1/3 to both x and y. And so if I multiply to both x and y, I would get negative 1, 2, 0, 2, 1, 1, and negative 1, negative 1. I'm going to graph both, and again, a little color would probably be nice. So I have negative 3, positive 6, 0, 6, 3, 3, and negative 3, negative 3. So it's a pretty big figure here. And this was K, L, M, N. Now, doing the new figure, we'll go ahead and change colors. We'll go to red this time. Negative 1, positive 2, 0, 2, 1, 1, and negative 1, negative 1. So you'll notice this figure looks exactly the same. It's just 1/3 the size. By the way, we haven't talked about this yet, but all the angle measures of two figures would actually be the same. You're not changing the angles, you are merely changing the size of the figure. That's called a dilation. Try this one on your own. Go ahead and hit the pause button. See if you can do it by yourself. All right, welcome back. Let's see if you get the correct answer now. P prime, Q prime, R prime, and I want a scale factor of, a dilation of 4. So negative 8, negative 4, negative 4, and 0, and 0, and negative 4. Graphing both. First one, negative 2, negative 1, negative 1, 0, 0, negative 1. So this is not a very big figure here. So P, Q, R. Well, let's go 4 times the size, a scale factor of 4. Now this is going to be a much bigger picture. Negative 8, negative 4. Negative 4, 0. And 0, negative 4. So this figure is 4 times as big. Try this on your own. So hit the pause button. All right, welcome back. Let's see if we can get all these now. 0.4. So I'm going to multiply 5 times 0.4, which is 2, and negative 2, times 0.4 would be 4, and negative 2, and 4, and 2 again. So the original 5, negative 5, 10, negative 5, and 10, positive 5. So this is P, Q, R. And now I want to figure that is 0.4 the size. We're talking about a reduction, right? It's going to be smaller. So 2, negative 2, 4, negative 2, and 4, positive 2. And so this figure is 0.4, P prime, Q prime, R prime. Scale factors can be negative as well. Now, when you do a negative scale factor, you're actually doing not only the dilation, but a rotation of 180. So you can do a negative scale factor. You're just doing 2 things at the same time. Notice this. This would just be a normal scale factor, and then that would be a negative scale factor. So it's not only is it a dilation, it's then also a rotation of 180 degrees. So here we go. I have a scale factor of -1/2. So I'm going to do my points again. So F prime, G prime, and H prime. And I'm going to multiply by -1/2. So +2, +1. +1, -2. And then +1, +1. So the original picture, -4, -2, -2, +4, and -2, -2. There's the original, which is F, G, and H. Now for my image, my new +2, I'm going to change colors here. This always makes it a little bit easier to see. +2, +1. Of course, it helps if my colors work. 1, -2, and 1, 1. So not only did it make it smaller by 1/2, then it also rotated it 180 degrees. So we got F prime, H prime, and G prime. Hit the pause button. See if you can do this one by yourself then. All right, welcome back. P prime, Q prime, R prime. We're multiplying it by a -2, which ultimately ends up being a dilation that is rotated 180 degrees. So -2, -4, -6, -2, and -2, +6. So the original 1, 2 for P, 3, 1 for Q, and 1, -3 for R. So there's the original. Now, remember, I'm rotating 180 degrees and making it, enlarging by 2. So -2, -4, -6, -2, sorry, and then -2, +6. So we have P prime, Q prime, and R prime. See the picture rotated 180 degrees. Let me put in a color here. It rotated 180 degrees. My color's not working. Rotated 180 degrees and then double. Scale factor. A lot of times you'll have a picture that you'll enlarge or reduce. So in this case, you are making your own photos. Your original photo is a 4x4. So 4x4. Your new photo is a 1.1 by 1.1. And I did that backwards. Give me a second here. The original is 4, and the new is 1.1. What is the scale factor? Now, technically, you shouldn't have a decimal. You shouldn't have a decimal within a fraction. So we're talking about 11/40ths. Notice I moved it 1 decimal place, so I move it 1 decimal place on the bottom. So my scale factor is 11/40ths. This happens a lot. A lot of times when you're working in a photo situation or you have a picture on a Microsoft Word document or something, you'll hit the corner, you'll drag it, you'll enlarge it. When you edit photos, sometimes you will crop it and then zoom in on it. Again, you're enlarging a picture or reducing a picture for that matter. So here we have a situation we're going to use a magnifying glass, and the object is 6 times the actual size. So if the actual size of the spider is 1.5 centimeters, then what would it look like under a magnifying glass? So if I multiply that by 6, it would end up being 9 centimeters. So it'd be a pretty big spider after you looked at it in the magnifying glass. Now, this doesn't happen very often, and I don't know, we'll have a few homework questions on it, but it won't be something big that we end up talking about. Horizontal stretches. If I only stretch something in one direction, I'm not doing it to the entire figure. Okay? These are non-rigid transformations. Okay, now dilation, okay, changes the, such as dilation changes the size and shape, so the transformation is non-rigid. There are other transformations that are also non-rigid. Two examples are shown. It's important to pay close attention to whether the non-rigid transformation preserves the lengths and the angles. So if I stretch B only, notice that I only moved B, this would be considered a horizontal stretch. And if you only stretch one point, so notice we're only stretching A here. Only stretching A, that's a vertical stretch, that changes the shape completely. At least with the dilation, you're blowing it up and you're making all of the sides, though, bigger. This one, you're only increasing one side of the triangle. SAT question now. The table shows the results of a poll. Total 803 voters selected at random were asked whether a candidate would vote for the upcoming election. According to the poll, there's 6,424 people vote in the election. By how many votes would Angel Cruz expect to win? Now, notice the ratio if you only looked at 803. So the ratio for that situation, and now we're going to expand that to all voters. I like to consider this a proportion. So if we have 483 voters out of the 803 voters, then how many voters should we expect out of 6,424? And so I would cross multiply 803x, and my board's going crazy here, 803x, and now we're going to have a little bit larger number, 483 times 6,424, and I would get 3102792. Divide that by 803, and x would equal 3864. So we are expecting we're expecting 864 votes for Angel Cruz. That would mean subtracting 6,424 minus the 3,824, that Terry Smith should expect 2,600 votes. So by how many votes would he win by? Oops, and I subtracted wrong. 6,424 minus 3,864. It's 2,560. Sorry about that. Wait a minute, the answer is not there. And so by how many votes should we expect? He's going to win by 1,304 votes. Your homework assignment is the 4-5 worksheet. If you have any questions, please make sure that you talk to your teacher, and good luck.